Hello and welcome. For this video we are looking at the test for positive ions, and on this particular slide we're looking at flame tests, and then we're going to look at the other kind of test that you can do where you use sodium hydroxide solution. So in terms of our flame test, the way we do this is we have a wire loop, usually made of a substance called nichrome, which is very unreactive and resists heat quite well, and we can have this loop that we can dip into our unknown substance. So we're testing here to see if there are any positive ions in our solution here. It doesn't have to be a solution, but I've got a solution here. But before we dip it in our solution, we have to actually dip our loop in hydrochloric acid first, concentrated hydrochloric acid. We heat it and then we dip it in the hydrochloric acid again, and that's just to make sure there's nothing on there at all other than the solution that we are going to be testing. So we dip into our solution, and then we have to use a blue Bunsen burner flame to see what we have. And if we put our loop in there like that, we can get a change in the color of the flame, and in this case it's gone what's supposed to be crimson. So this color is supposed to be crimson, and that will tell us that we have positive ion called lithium. There are lithium ions present in our compound that we are testing. Now unfortunately the rest of this really, or the rest of the flame test stuff, is all just memory work. So there's 5 that you've got to know and remember, 5 colors and 5 positive ions. So they are as follows. So if we have a yellow flame, that will give us the sodium ions, shows that sodium ions are present. The lilac color is potassium. Red will give us calcium. That's not a minus, that's going to be a plus when I show you the next picture. And green is barium. Now the only other thing to mention here is sometimes they call this brick red, and this crimson color is very similar to a red color, but it's actually just a bit of a deeper red. But just say the word crimson, that's fine for lithium. So there they are. These are the tests for the flame test for positive ions, and unfortunately, as I said, you have to know and remember these. There's only 5 if you go over it once or twice. I'm sure you can just sort of force it into your brain for the exam tomorrow, if you've got it tomorrow. If not, if you're watching it another time, it's not tomorrow. Don't what am I talking about? Okay, let's move on. So there they are, the 5 flame colors and the 5 positive ions that you should be able to identify from those colors. The next one is again some more memory work, and we have an unknown solution that we want to identify. And again, remember, we are testing for positive ions here, and we're using the reaction with sodium chloride. So here we have an unknown solution, and we want to see which positive ions are present. And the key and first step here is to add sodium hydroxide. Okay, so that's the first step. And once you do that, you get either a white precipitate or a colored precipitate. Okay, and by precipitate we mean a solid substance that comes out of the solution when you add the sodium hydroxide. So here I've got a white precipitate that I've shown in this little diagram here. Now that's not the end of it for the white precipitate, because we need to add another step, and the other step would be to add some excess sodium hydroxide. So excess, it basically just means add more sodium hydroxide, and if the precipitate dissolves and disappears into the solution, i.e. dissolves, we know we have aluminium ions. If the precipitate doesn't dissolve, then we know we've got something else other than aluminium, and it could be one of 2 things, and it could either be magnesium or calcium, but we won't be able to tell because the precipitate has not dissolved, it's still there. How do we find out which one it is? Well, we have to then do a flame test, and if we get a red color, that will tell us it's calcium, because if you look back on our flame test, red or brick red, that tells us it's calcium. And if not, if there's no color at all, it's magnesium. Okay, so there's no specific color that you have for magnesium. You would just get no color shown at all with the if the ion was magnesium. Now if we don't get a white precipitate at all, but we get a colored precipitate, well, there's 3 that you need to know, and the first one is brown. If you get a brown precipitate, formed here as shown in this little diagram, that means you have iron 3 or iron with a 3+ charge. Iron 3 we refer that to that as. If you get a green color, that's iron 2, so we have iron 2 ions, and if we get a blue color, that means we have copper 2+. Okay, so copper ions, we just refer to that as copper, and these are the colors roughly indicated in these diagrams here. Okay, so if you look at this screen as the whole screen, it does look kind of confusing, but if you break it down, it's relatively straightforward. It's not that difficult. For our positive ions, we just add sodium hydroxide as the first step. If we get a white precipitate, we add more sodium hydroxide. If the precipitate dissolves, we know it was aluminium ions that we had, and if it does not dissolve, we have to then distinguish with the flame test. Red will tell us calcium, no color will tell us it was magnesium. If we don't get a white precipitate but a colored precipitate, then brown is iron 3, green is iron 2, and blue is copper. Okay, so a lot of memory work, I'm afraid, but it's there, and probably need to go over it maybe 1 or 2 times. But other than that, that's me done for this video. Thank you for watching. I'll see you again